Hello, my name is Carl Perez. I'll be teaching Math 111 OLC. It's college algebra, and today we're going to cover Unit 1, Section 1.3. It's one of three sections we're going to be covering in Unit 1, entitled Operations with Real Numbers in our textbook. Basically, we're going to review adding, multiplying, subtracting, and dividing real number expressions, particularly fractions. Oh, forgive me, by the way, I've got a little bit of a cold, so we'll have to trudge on, and I hope it doesn't annoy you too much. Also, powers and roots of real numbers, and especially order of operations, we'll get to towards the end of the section. All right, let's consider this first problem here, minus 11 minus 1 minus 5. Well, of course, we know from our previous algebra courses, when I subtract a negative, it becomes positive. So I'll get equivalently 11 plus 1 minus 5. Minus 11 plus 1 is minus 10. Minus 5 is minus 15. Should be our correct return for that problem. Alright, hopefully not a big deal there. How about something like this? Minus 14 thirds minus 7 sixths. Again, excuse me. Here we're asked to subtract one negative fraction from another negative fraction. Well, somewhat similar in that when we subtract a negative, it becomes positive. Negative of a negative is positive. Oops, forgive me. That should be a minus 14 thirds. Thank God we have a nice eraser here. All right, before we add now, we change the sign of that negative fraction. Before we can add these fractions, we've got to get a common denominator, of course. So I'll take this minus 14 thirds and multiply top and bottom by 2. I'll get minus 28 then over 6 plus 7 sixths. And if I combine these, I get minus now 21 sixths, now that my denominators are common. Of course, 3 is a common factor. I divide 3 both into numerator and denominator. 3 goes into negative 21 negative 7 times, and 3 goes into 6 twice. So your proper, completely simplified answer for that problem is minus 7 halves. Alright, let's try another one. Right up the ladder here. 7 fourths plus minus 3 halves. Well, somewhat similar to the one we previously did. We need a common denominator, of course. We're adding a negative, so no change of sign here. I'll run 7 fourths plus minus 3 halves. I've got to get a common denominator here of minus 3 halves with a denominator of 4. So I'll multiply top and bottom by 2. So I'll get 7 fourths plus minus 6 fourths, and that, of course, reduces to 1 fourth. Okay? All right, let's talk about multiplying some real number type expressions. Kind of hard to get in frame here. All right. And how do we multiply real numbers? All right. Write down an expression here. I get minus 4 times minus 9 times minus 3. Well, as you know, multiplication is associative and commutative. That means I can multiply any two first. I've got to multiply, well, let's see, minus 9 times minus 3. A negative times a negative is a positive. So, of course, I'll get minus 4 times minus 9 times minus 3 is positive 27. Alright, so that doesn't look like such a big deal. What's 4 times 27? Well, 4 times 27, 4 times 7 is 28, carry the 2. 4 times 2 is 8, 9, 10. So I get a final return of negative 108, multiplying those three negative integers together. Alright, hopefully not much of a big deal there. How about multiplying fractions? 4 thirds times minus 1/8. Well, let's see, the easiest way to do this is to cross-cancel. 4 goes into 8 twice. I can't do any cross-canceling or simplification across these fraction bars. Minus 1 and 3 are what they call relatively prime. So now I'll just multiply across. I end up with a minus 1 in my numerator, and 3 times 2 is 6 in my denominator. So that's my proper return for that fractional multiplication. Let's try another one. Minus 7/9 times 3/16. Again, the proper way to do this is probably to cross-cancel. I can't simplify any of these fractions to begin with. 7/9 is already simplified. 3/16 is already simplified. What I can do is cross-cancel. 3 goes into 9 3 times. Remember, every time you leave a cross out here, that's like an invisible factor of 1 that now appears. Minus 7 times 1 in the numerator is minus 7. 3 times 16, well, 3 times 6 is 18. Carry the 1. 3 times 1 is 48. So I end up with a minus 7 48ths as a return for that problem. Alright, so we did 3 simple multiplication type problems, multiplying real numbers. How about division? See, how about 2/3 divided by minus 3/5? Well, as you probably know, when we divide fractions, some people say keep, change, flip. Back in the old days, we used to call it invert and multiply. Basically, I'm going to take that divisor fraction, minus 3/5, and invert it, and that turns it into a multiplication problem, which we should be able to handle pretty easily. Excuse me. No cross-canceling here. These fractions cannot be simplified. The numerators and denominators are relatively prime. 3 doesn't go into 5. 2 doesn't go into minus 3. So I have no choice but to multiply across here once I've done that flip. So 2 times 5 is 10, and 3 times minus 3 is minus 9. So my final return is 10 over negative 9. Notice I can absorb that negative sign in the numerator or denominator and state equivalently that my answer is either 10 over minus 9, equivalently minus 10 over 9, or even stick that negative sign outside of that division operation and say the answer is minus the negative of 10/9. Okay? Alright. Let's go on to the next one. How about minus 1/2 divided by minus 6? Well, how are we going to work this out? How are we going to keep, change, flip when there is no fraction visible in that second divisor slot? Well, of course, we all know that minus 6, a negative whole number, an integer, a negative integer, has an invisible divisor of 1. I can rewrite minus 6 as minus 6 over 1. And then I can apply my keep, change, flip attitude, my keep, change, flip motif in dividing fractions. So I turn it into a fraction multiplication problem by inverting the divisor fraction and multiplying by the numerator fraction. Alright, now, and again, no simplification I can do really. I can't cross-cancel anything, so I'll just multiply across now. I end up with minus 1 over minus 12, and I would not accept this as a final answer. You really need to simplify as much as you can at this level. And of course, a negative over a negative is a positive 1/12. Alright. Let's go on to the next one. How about minus 7/8 divided by 2/3? Alright. Again, I will keep, change, and flip. Or like we used to say, invert and multiply. Again, no simplification can go on here. I can't cross-cancel. I can't simplify the fractions, so I'm just going to have to multiply across. I get minus 21 in the numerator and 16 in the denominator. And that would be my final return there. Alright, so that's a few examples of dividing fractions. Let's talk about powers. Powers of real numbers. Minus 2 to the 4th power. What's that all about? If I ask you to evaluate that on a test day, well, minus 2 to the 4th power, all that means, as you probably know, is you're going to multiply 4 factors of the base together. Minus 2 times minus 2 times minus 2 times minus 2. Again, multiplication is commutative and associative. You can multiply any two first. in order from left to right, technically. Alright, so let's do minus 2 times minus 2 first. That's going to be 4 times minus 2 times minus 2. And then technically this should be the next step. 4 times minus 2 is minus 8. And then 8 times minus 2 is going to be, of course, positive 16. So minus 2 to the fourth power would return positive 16. Right? Let's try another one. Let's try putting some fractions to some powers. 3/4 squared. Well, what does 3/4 squared mean? Well, just what it says. You take 3/4 and multiply it by itself. Again, no cross-canceling can go on here. The fractions are already simplified, so I have just multiply across now. 3 times 3 is 9, over 4 times 4 is 16. So 9/16 is the return there. Alright, so we can take powers of real numbers also. How about roots? What's the square root of 121? Well, as we probably all know, the square root of 121 is 11, because 11 squared is 121. The square root of 121, by definition, is the number we square to get 121. That's kind of the reverse, or really the inverse operation of the square operation, right? The squaring power. How about something like this? Minus the square root of 49. Well, I'll cover up well, I can't really cover it up here on the screen. That's too bad. I'll just consider the square root of 49 first. The square root of 49 is 7, and then I'll negate later. So this returns a negative 7. If the negative sign is outside the square root sign, that's fine. That's totally allowable, and in this case we'll get a negative return. How about the square root of 1/4? Well, what number do I square to get 1/4? Again, by definition, the square root of 1/4 is the number you square to get positive 1/4. And of course, that's 1/2. 1/2 because when I square 1/2, I get 1/4. 1/2 is the fraction I square to get 1/4. Alright, I don't want to make this too soft here. The square root of 36, of course, is 6, because 6 squared equals 36. Minus the square root of 100 is minus 10. The square root of 4/25. By now you've probably figured out you can take the square root of the numerator and denominator independently when evaluating these roots. The square root of 4 is 2, and the square root of 25 is 5. So the square root of 4/25 is 2/5. The square root of 1, what is the number I squared to get 1? Well, of course, 1 to any power is 1. Alright, and I think we're ready now to go on to order of operations. Order. Oh, let me get my eraser out. Order of operations when we've got a bunch of these operations stacked one on top of the other. Oh, excuse me. I'm almost out of room in this screen. Let me get another screen, and we'll be right back. There we go. Right up to the end. Get as much room as I can here. As much room on the left as I can. Alright, very good. Alright, let me relabel this screen. Order of operations. Well, the idea is when we stack up a bunch of these operations one on top of the other, we've got to decide upon an hierarchy or an order of operations so we get exact, consistent values from person to person or application to application. Alright, well, I imagine we've heard of Pemdas. And there's all kinds of silly acronyms to help you remember this. Probably the most popular is Please Excuse My Dear Aunt Sally. Regarding order of operations, when you've got more than one operation pending, we always do the parenthetical operations or the parentheses embraced operations first, Once those are cleared, we go down to the exponent. Exponents are done first. Then multiplication. Well, let me change this a little bit. There's a popular fallacy that goes on regarding multiplication division. It's the next level is multiplication or division in order from left to right. So not necessarily multiplication first. It's division or multiplication, whichever comes first, in order from left to right. Of course, assuming once the parentheses and exponents are cleared. And then addition or subtraction, again, in order from left to right. Not necessarily addition before subtraction. Subtraction could come first if it's the first in order from left to right. So please excuse my dear Aunt Sally. Should help us get us through these order of operations problems. All right, so let's see. We've got 1, 2, 3 operations going on in this problem first. We've got addition, multiplication, and exponents, and only one gets done first. That's the exponent operation. So I'm going to do the exponent operation first. Minus 3 squared is going to be 9. Okay, positive 9, right? All right, what happens next? Well, do we add or multiply? Of course, you're going to say multiply. Multiplication takes precedence always over addition. So 9 times 4 is 36. And then our addition is our last step. Minus 5 plus 36 is positive 31. And that's our final return for that simple order of operations problem. All right, let's do another one here. Minus 10 divided by 5. Minus 5 times 3 plus 6. All right, let's see. We've got a division, a subtraction, a multiplication, and an addition. And technically, this division gets done first, right? This division, there's no exponent operations, there's no parentheses operations included. So I'll do minus 10 divided by 5 first. Minus 10 divided by 5 is negative 2. And if you read a new line of code for each and every step, it could get a bit tedious. Once we get a little practice down, we may skip a few steps. Do some of these operations in our heads, right? But not yet. All right, so minus 10 divided by 5, that's the first operation. That gets done first, is negative 2. Now we've got a minus, a subtraction, a multiplication, and an addition. And of course, the multiplication gets done first of those 3 operations. So minus 5 times 3 is negative 15 plus 6. All right, technically this subtraction happens before this addition. Minus 2 minus 15 is minus 17 plus 6, and my final return then would be negative 11. All right. Let's try another one with some exponents. Minus 9 plus 2 times minus 4 squared equals. All right. We've got an addition, a multiplication, and an exponent. Exponent will get done first here. Minus 9 plus 2 times minus 4 squared is positive 16. Then, of course, I'll do the multiplication. Minus 9 plus 32. And minus 9 plus 32 is, of course, 23. Is the final return for that example. All right, I'm going to start getting a little nastier here, stacking up more and more of these operations. How about something like this? I have to crowd this in a little bit. 2 plus 3 times minus 2 minus 8 times 4 minus 3 squared equals. All right. So what we've got here, we've got it all in this problem. We've got parenthetical operations. Actually, we've got parentheses operations nested within other parentheses operations. Excuse me. So basically what we do is when we've got nested parentheses, we work our way out, work from the inside out. So I'm going to look at this little universe first. This is the innermost nested set of parentheses, and I'm going to leave all other operations pending until I complete that. Alright, of course I'll do 3 squared first. 3 squared is 9, and 4 minus 9 is minus 5. So that innermost set of parentheses turns into a minus 5, right? And things look better already. Alright, the tendency is to do this 2 plus 3 operation too early, but no, we're going to leave it hanging. What gets done next? Well, within the brackets now, I'll do this multiplication before this subtraction. Get minus 8 times minus 5 is going to be a positive 40, right? 8 times 5 is 40. So get 2 plus 3 times minus 2 plus 40. Made the square brackets a little too big there. Alright. 2 plus 3. All right, so really the square brackets turn into a 38. Alright, now I'll work this out. Again, don't do 2 plus 3. This operation actually gets done last. Right. First, we got to do this operation. 3 times 38. What's 3 times 38? I'm going to say, well, 3 times 8 is 24. Carry the 2. 3 to 9, 10, 11. 2 plus 1, 14. Let me check that. 90 plus 24. Yeah, 114. And 2 plus 114 is 116 would be the proper return for that stacked up bunch of nested parentheses. All right, let's try another one a little bit harder. 5 minus 3 times minus 2 times 5 squared minus 3 cubed plus 4 minus 1. A lot going on here in this problem. Again, I'll zoom in on my innermost set of parentheses and work from the inside out. Make a note of that, work inside out when doing these parentheses type, nested parentheses type simplifications. Leaving all other operations pending, I'm going to say 5 squared is 25 minus 3 cubed is 27. So 25 minus 27 is minus 2, is it not? And again, I'll just copy the other stuff untouched. So that first innermost nested set of parentheses turns into a negative 2. Alright, let's carry on now. 5 minus 3 again, don't do that operation first, it actually gets done last. Alright, within the brackets now, I'll do minus 2 times minus 2, that's positive 4, and so this expression turns into a 4, and 4 plus 4 is going to be 8, so the square brackets in essence turns into a positive 8, and now it's a breeze, right? So I got 5 minus 3 times 8 minus 1. Again, the multiplication first. Negative 3 times 8 is negative 24. Alright, so 5 minus 24 is negative 19, is it not? And negative 19 minus 1 is negative 20. Let me check that. 5 minus 24 is negative 19, and minus 1 is minus 20. Looks good to me. So we put a square around it and go on to the next problem. Alright, more order of operations. How about order of operations involving fractions? A third times a sixth minus 1/3 squared. Kind of slipped there. Alright, how are we going to grind this out? Well, again, I'm going to multiply. Let's see, consider what we've got here. We've got 3 fractions, and we've got a multiplication, a subtraction, and an exponent. And only one of these operations gets done first, so formally it's the exponent gets done first. Let me take care of that. Minus 1/3 squared is going to be positive 1/9, is it not? A third times a third is 1/9, and negative times negative is positive. Alright, so let me rewrite that. This kind of blurbed a little bit. Alright, now it's turned into problems like we had done before. Alright, I'll take it a step at a time. So now we've cleared the exponents. We'll do this multiplication now next. That's next on the food chain. A third times a sixth is 1/18. And now I've got to subtract these two fractions. Of course, I need to common denominator. 1/18 minus, well, 1/9 is 2/18, multiplying top and bottom by 2. And 1/18 minus 2/18 is negative 1/18. So that big mess that we started with reduces to a little negative fraction called minus 1/18. Okay? All right. The next thing the book talks about is evaluating expressions. Let's see. Evaluating expressions. Here we go. Evaluate. Well, evaluate means get a value out of it. In other words, your answer should turn into a number, no expression. Let's see, if I've got minus 1/2 times a squared, okay, I'm going to evaluate this if a equals minus 2. All this means is you've got to plug in a minus 2 into this variable expression and grind out a value according to your order of operations. Alright, so I'm going to do just that. I'm going to plug in minus 2 for a and evaluate. Alright, so we've got a multiplication and an exponent going on here. Exponent, of course, gets done first. Minus 1/2. Hang on, my pen slipped a little bit. Minus 1/2 times, well, let's see, minus 2 squared is positive 4, is it not? And 2 goes into 4 twice. 2 times minus 1 is minus 2. Excuse me. So your final return is the value minus 2. Alright, let's talk about another one. Let me get a fresh screen here just in case. Are we okay here? As much room as we can here. Alright, how about this? Evaluate. Minus a square root of b. It's a b there. Erase it. Minus a square roots of b plus 3c cubed over c times c minus b if, I'm going to give you values for these a, b, and c values for variables. A equals minus 2, b equals 9, and c equals minus 1. Alright. So wherever I see an a, I'm going to plug in a minus 2. Wherever I see a b, I'm going to plug in a 9. And wherever I see a c, I'm going to plug in a minus 1. And then reduce the expression according to my order of operations. So c is minus 1, and minus b is 9. Alright, so let me check that. Minus 2 times the square root of 9 plus 3 times minus c squared, minus 1 squared. I'm sorry, 3 times minus 1 cubed, that looks good, divided by minus 1 times minus 1 minus 9. Alright, looks good to me. Alright, so now let's grind it out. Now, let's see, let's take this a longer view here. The fraction bar really acts like two giant symbols of grouping, isolating numerator for denominator. So the first thing I want you to notice is you can really evaluate the numerator and denominator independently. Alright, let's check out the numerator, and I think we could combine some steps here. We've got the numerator being two groups of operations being separated by a plus sign, so really I can evaluate the two parts of the sum here in one step and then add them. Minus 2 is 2, and the square root of 9 is 3, right? And I know that 3 times 2 is 6, so I can clean up some things, combining some steps here rather than writing a new line of code for each possible step. You'd be here forever. Minus 1 cubed, minus 1 to the third power, negative 1 times negative 1 times negative 1 is, of course, negative 1. And negative 1 times 3 is negative 3. All right, and of course I can do that numerator in my head. 6 plus minus 3 is, of course, 3. Now let's focus on the denominator. Let's see, I'll go to these innermost set of parentheses. Minus 1 minus 9 is negative 10, and then minus 1 times negative 10 is positive 10. So this big nasty expression for the values of a, b, and c given reduced to a humble 3/10 fraction. All right, we've reached the 30-minute point, so I'm going to conclude this video lecture for Unit 1 or Section 1.3 in Unit 1. Be sure to complete all homework exercises before the online exam, before attempting the online exam. Again, the homework exercises will be posted in a Word file on the Angel page for this course. And also, let's see, coming up in 2 separate video lectures, Section 1.5, which talks about solving equations, and Section 1.7, basically word problem type applications in solving equations. So let me put that down. Solving linear type equations, and then applications of solving linear equations, typically done in word problem scenarios. Alright, that's going to come up in 2 separate video lectures. Alright, we're approaching the 32-minute point of this video lecture, so this concludes Unit 1, Section 1.3, Operations with Real Numbers video lecture. That is all.